So, hello and welcome to lesson 16 in our study of scientific computing, where we are learning the Python programming language. So, we are still on the Scipy, right? And in this video, we learn how to do linear algebra and optimization with Python. Okay, so I'm Boydo Randolph, a final year student of mathematics at the Kwame Nkrumah University of Science and Technology, KUST, and I'll be taking you through this lesson. Okay. So with linear algebra, we will treat the following. So how to solve system of linear equations using Python, how to find eigenvalues and eigenvectors, how to find norms and some metrics operations. Okay. So let's consider this system of linear equations here. So we want to solve this. So in solving system of linear equations, we use the solve method to do that. Okay. So when you are solving system of linear equation, what we do is that we write the matrix. We write two matrix out of it called the coefficient matrix, and we have a vector, right? So the coefficient matrix for this system of linear equations, for instance, is going to be 1 minus 1, 2 minus 1. That's the first row. The second row, 1, 0, minus 1, 1. The third row, 2, 1, 3, minus 4. And the last row, 0, minus 1, 1, minus 1. And our constant vector is going to be 6, 4, negative 2, 5, right? So we just have to do that. So now let's learn how to solve that system of linear equation we had there using Python. So we import scipy dot linear algebra as what ln, right? Then we first have to create the coefficient matrix. So we import numpy as np, and a is equals to, so the coefficient matrix was what 1 minus 1 2 1 1 0 minus 1 1 2 1 3 4 0 minus 1 1 minus 1. So by now you should know how to create a matrix in Python using an numpy. We've done that. Then we also have to create the constant vector, right? Our vector, our b vector, which was 6 4 negative 2 5. So now we have it. We have the coefficient matrix, we have the vector b. So to solve this, we just use a function in Python called solve. Then it takes two arguments, the coefficient matrix and the column vector. So solve AB, then to give us the answer. So this answer means x1 is 5.5, x2 is negative 3.5, x3 is negative 0.5, and x4 is negative 2. So you can use this to solve any system of linear equation that you have, right? With the coefficient matrix being a square matrix. Okay, so now how to find eigenvalues and eigenvectors. So to find eigenvalues and eigenvectors, we are going to illustrate it using this matrix here, 3 0 minus 1 1. So to find the eigenvalue and eigenvector, we import scipy dot len arg as what ln, then we import numpy as np, right? So a is equal to the matrix that we had, which was 3 0 minus 1 1, that you can see here. Then we are going to do multiple assignments here. So argval and argvec. So the argval is going to store the eigenvalues, and the argvec is going to store the eigenvectors, and this is equal to ln because we're importing scipy dot linear algebra as ln dot eig of e, right? So when you do this, and you should call EIGVAL, which contains the eigenvalue to give the eigenvalue. So it is 1 and 3, right? So 1 and 3. So actually, it gives it to you in a matrix, in a complex number form. But you see, this is 1 plus 0j. That means the imaginary part is 0, so it is just 1, and this is 3. And if you should type the second component, argvec, it will give you the eigenvector, right? So know that this is how to find eigenvalues and eigenvectors in Python using the scipy. There are other ways you can do that though, but this is one of the ways, okay? Then now how to find norms, right? So you learn how to find the one norm, the two norm, the infinity norm. You can find any kind of norms, right? With it. So we have this matrix here, that's what we are going to use, right? So we first have to import scipy dot linear algebra as ln, Then we import numpy as np so that we can define our matrix A, right? So to get the one norm, it is norm, it takes two arguments, right? So there's a variable containing what? Our matrix. And the ORD here means the type of norm you want to find. So here we are saying 1. So that means you find the one norm for us and it gives us the answer 4. If we do the order to be 2, it will find the 2 norm for us, or a Frobenius norm, right? Which is 3.1795. And if we should do the norm of A order equals infinity to give us the infinity norm, okay? So that's how to find norms in Python using the Scipy. So now let's go to the last thing that we want to talk about in this video, optimization, right? Okay. So when you need to optimize the input parameters for a function, scipy.optimize contains a number of useful methods for optimizing different kinds of functions. And some of them are, so we have the minimize scalar and minimize, which is used to minimize a function of one variable and many variables respectively. We have care fit, which is used to fit a function to a set of points. We have root scalar and root, which is used to find the zeros of a function of one variable and many variables respectively. And we have linear programming, which is used to minimize linear objective function with linear constraints, right? So that's used to perform linear programming calculations in Python. Is that not wonderful? So let's illustrate an example here. So we want to minimize this function here, f of x equals s squared minus 2x plus 5, right? And s is um, contained in the interval, close interval, -1, 4, right? So we want to do this. Okay, so to do this, oh, I think I just provided the solution without how we solved it. Okay, so we are going to do that. It's very simple. Okay, so first of all, we are going to import scipy.optimize. I want to import that up there. I think it's a cool name. Then we have to define the function that we want to minimize, right? You say we should minimize this function. So the function is s squared minus 2x plus 5. Hmm. 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 So there's it, s squared minus 2x plus 5. Okay. Okay. Then I want to minimize it, right? And it is just one variable, right? So if I do minimize scalar, if it was several variables, it would just be minimized without bringing a scalar, right? Then what's the function I want to minimize? F. So if I want to just minimize f, and you see for instance here, where is my cursor? Okay, this is it. So for here, we are saying that x is contained in what? -1 for, like, in the interval. If let's say we're not having this portion there, it was just a function, then we will just do this and it will give us the answer. So it will tell us that the minimum value is 0.999999, which is 1, approximately 1, and the functional value is 4, right? Right, see in our case, we had some interval then. So to bring that, we will use bracket equals, right? And the interval was -1, 4. Okay. So this gives us the answer. So x is what 1.0000 here, and the functional value is what 4. And you see, it gives us whether we have a success to be true or not, right? So you know, you can. It's not every function that you can find the minimum or the maximum of. So for instance, if you can't find the minimum value of the function you gave, then the success is going to be false. Okay, so you see, we just introduced you to just a smaller portion of it. So you can also use this if you want to optimize a function of like two variables or more. Now I use minimize linear programming constraints and the rest. And so you can learn how you can read on them and learn how to do all of them. They all follow the same procedure and it's very very simple. Okay, all right. So that's what you can see here. So interpretation is that the minimum value is 4 and it occurs at x equals 1. So thank you. Right, these are the few functions I'm going to teach you as far as the Scipy is concerned. But note, you can do a whole lot of things with it. Okay, so you'd have to man up and learn more, right? So yeah, see you in the next lesson. So the next lesson, I'm going to teach you the matplotlib dot pyplot model, right? The matplotlib library, which is used in Python for data visualization, right? For plotting graphs and visualizing images, graphics, and what have you. Okay, so see you in the next video.